Good morning everyone, my name is Jay Shirisha. I am from CSE MLC section. Today I am going to describe about definition of non-homogeneous equation. Now, definition of non-homogeneous equation. A non-homogeneous equation is a mathematical equation that contains at least one term that is not linearly independent on the variables. This means the equation includes a constant or independent terms that cannot be expressed as a linear combination of the other terms. Characteristics of non-homogeneous equation. Varied solution, mixed terms using solution. Varied solution. Non-homogeneous equation can have both a general solution and a particular solution, unlike homogeneous equation which only have a general solution. Various solution, just we can know that non-homogeneous equation can have both general solution and particular solution, unlike homogeneous equation which only have a general solution. Mixed terms. This equation contains mix of dependent and independent variables. Mix of dependent and independent variables. Unlike homogeneous equations which only have dependent variables. Unique solution. The solution to a non-homogeneous equation is the sum of the general solution of the associated homogeneous equation and particular solution. Unique solution. The solution to a non-homogeneous equation is the sum of the general solution of the associated homogeneous equation and particular solution. Now, difference between homogeneous and non-homogeneous equation. Defining characteristics, solution approach, applicability. We can show the difference between homogeneous and non-homogeneous equations by the defining their characteristics and solution approach and applicability. Homogeneous equation have no constant terms, while non-homogeneous equation have a constant term on the right hand side. Homogeneous equation have no constant term, while non-homogeneous equation have a constant term on the right hand side. Solution approach. Homogeneous equations can be solved using techniques like separation of variables or undetermined coefficients, while non-homogeneous equations require a particular solution in addition to the complementary solution. Now, applicability. Homogeneous equations model systems in equilibrium, while non-homogeneous equation describes systems with eternal forcing or inputs. Homogeneous equation model system in equilibrium, while non-homogeneous equation system describes systems with external forcing or inputs. We can explain applicability in non-homogeneous equation by the external forcing or inputs. Now we can see that methods for solving non-homogeneous equation. Variation of parameter, Laplace transform, undetermined coefficients. Variation of parameters. This method involves finding a particular solution by assuming the coefficients of the homogeneous solution are variable and solving for them. In variation of parameters, methods involves and coefficients of the homogeneous are variables and solving for them. Now, second one, undetermined coefficient. This approach assumes a particular solution has a specific form based on the non-homogeneous term, then solves for the unknown coefficients. Laplace transforms. Laplace transforms can be used to convert non-homogeneous differential equation into algebraic equation that are easier to solve. We can convert that non-homogeneous differential equation into algebraic equations. It makes easier to solve the problem of non-homogeneous. Now, particular solution for non-homogeneous equation. Complementary solution variation of parameters, undetermined coefficients. In complementary solution, the particular solution represents a specific solution to the non-homogeneous equation, whereas the complementary solution addresses the homogeneous part of the equation. Now, variation of parameters. One technique for finding the particular solution is the method of variation of parameters, which involves modifying the coefficients of the complementary solution. Now, undetermined coefficients. Another approach is the method of undetermined coefficients, where an educated guess is made about the form of the particular solution based on the non-homogeneous term. Complementary solution for non-homogeneous equation. Homogeneous solution, particular solution, general solution. In homogeneous solution, the complementary solution for a non-homogeneous equation consists of the homogeneous solution, which is a solution to the associated homogeneous equation without the forcing term. Particular solution. The particular solution represents the specific solution to the non-homogeneous equation that satisfies the forcing term and is found using methods like undetermined coefficients or variation of parameter. General solution. The general solution to a non-homogeneous equation is the sum of the complementary homogeneous solution and the particular solution, providing the complete solution to the equation. Now, superposition principle for non-homogeneous equation. The superposition principle is fundamental concept in mathematics that applies to non-homogeneous equation. It states that the solution to a non-homogeneous equation can be expressed as the sum of the particular solution and the complementary solution. This principle allows us to break down the complex problem for solving a non-homogeneous equation into the simpler sub-problems, finding the particular solution and finding the complementary solution. The final solution is then obtained by combining these two elements. The superposition is a fundamental concept in mathematics that applies to the non-homogeneous equation. It states that the solution to a non-homogeneous equation can be expressed as the sum of the particular solution and complementary solution. Application of non-homogeneous equation. Engineering, economics and physics. In engineering, non-homogeneous equations are widely used in engineering to model real-world phenomena like electrical circuits, mechanical systems and heat transfer problems. Economics. Economists rely on non-homogeneous models to study market dynamics, consumer behavior and the impact of government policies. Physics. In physics, non-homogeneous differential equation describes the motion of the objects under the influence of external force such as gravity or electromagnetism. Limitations and assumptions of the non-homogeneous equation. Complexity, assumptions, boundary conditions, applicability. Non-homogeneous equation can be more complex to solve than their homogeneous counterparts as they requires finding both the particular and complementary solution. Assumption. Solving non-homogeneous equation often relies on assumption about the form of the particular solution, which can limit the range of problems that can be solved. Boundary conditions. Applying boundary condition to non-homogeneous equation can be more challenging as a particular and complementary solution must be considered together. In applicability, non-homogeneous equations are most useful for modeling real-world scenarios with external force or inputs but may not be appropriate for all types of problems. Conclusion. In conclusion, non-homogeneous equations are a crucial tool in mathematics modeling the problem solving. By understanding their unique characteristics and solution methods, we can gain valuable insights into complex systems and processes across various fields of study. Thank you.